So in order to be able to control this stepper motor, we have this little controller which allows us to isolate the power supply going to the stepper motor from whatever controller we're using to send this signal to it. We'll try and use this just using the power from the Arduino like we did with the servo motor. And again, since this is a small stepper, it should work under small loads. But if you want to try and run this under a larger load, or at a higher voltage, I suggest you run a separate power supply into the inputs on here. So because this one has male instead of female attachments, we're going to have to use some of our other sets of jumpers. So if you look in your kits, you should have jumpers that look like this that have a female on one side and a male on the other side. This is a ribbon cable, so you are going to have to go through and kind of separate some of these out to make them a little bit more convenient for you to use. I try to keep them a little bit together because it makes cable management a little bit easier. But if you want to have them all separate as individual cables, you can do that too. So let's go ahead and start by setting up the power. Oh, let's unplug our Arduino first. And we'll put the negative on here. And again, this chip is designed to take 5 to 12 volts, which is why the little 5 to 12 on the side here, but there's also a little negative and a positive. So kind of matching the convention on my stepper motor that I used before, I want to make the negative the brown and the positive the red. And try and push those on. If they don't fit, then it's usually because you have the connections rotated 90 degrees. They are a little bit wider in one direction than they are the other. So look and try and make sure you have those right in the right orientation. And once I've got those hooked up, again, I'm going to put the power, the red on the power line, and the black on my ground line. So that gets me the power set up, and I got to figure out which pins do I want to use to control these. Right now I have 10 through 13 is open on my board, so I'm going to make those my pin outs. And I'm going to try and keep them in the same order. So I'm going to get a set of 4 from my ribbon cable. Just tear that off like that. And I'm going to make 10, 1, and I'll try and make 4, 13 to keep these things consistent and easy to do. If you get these stacked up just nicely, they should go in and fit together. Again, if you have them rotated the wrong way, they won't. So just try and make sure you have them oriented correctly. So got those in there. Same thing on the other side here. I'm just going to scoot this a little bit over and get that untangled. Again, I'm just going to try and have, actually to keep these lined up a little bit better, I'll invert the order so I don't have to twist this cable. Yeah, and twisting it doesn't hurt. So I'll make our 1 on that side, 10 on this side, like we said. I did have to turn the cable around though. If you're having trouble getting all these to go in at the same time, then just do them one at a time. But if you hold them just right, they should all go in rather nicely. All right. So again, I've got the orange line on here is connected to my pin 10 on my Arduino. That's going kind of around and then into the what's called in 1 on this controller. And then yellow is in 2, green is in 3, blue is in 4. Then on the Arduino side, yellow is going into pin 11, green is going into 12, and then blue is going into 13. We are going to have to keep track of which of these pins are which going into this. And there are libraries you can use for these steppers. We're going to try and hard code it here at first, and if we have any issues with that, we can go into a library later on. But it's nice to kind of see how these work by coding it manually at least once. And then after you've done it once or twice and you kind of understand how they work, moving on to doing it using a library which has more kind of convenient functions built into it is helpful. All right, so we've got that wired up. Should be good. Let's move on to our code. We need to specify our pins for in 1, 2, 3, 4. So I'm going to make some space here at the top. Pins for the stepper. So I'm going to do in 1 pin equal to 10. And these are pretty self-explanatory, so I'm not going to bother putting a comment in for each one of them. And actually, when we get through this, maybe we'll go through and make this into a for loop to make things a little bit easier for us going forward. But for now, let's leave them separate just to keep it very explicit as to how we're doing this. Then again, we have to set our pin modes. We're going to set these all to outputs. And I'm just pasting these using Control V. And then to control this, I'm just going to set it up to basically go through and do 4 steps each time I go through the loop. So that way I'm starting at the beginning every time I go through. Again, this is a very basic control, but it works reasonably well just to show you how this thing works. Let's go ahead and do this at the top of the loop just to make it easier to read. So we're going to start off by setting all of the outputs low. Now what we want to do is we want to set one high, wait, and then do the next one high, and then low, and then wait, and then the next one high, and then low, and then wait. Another thing you can do, it's actually probably better for it just to do it this way. We can initially set these all to low, so it only has to run once inside the setup loop, just to save some code here. And then let's do pin 1 high. We'll do a short delay. Let's do a little bit longer than, let's do a half second. So 500 milliseconds, just so it's a little easier to see. And we'll set pin 1 low again. Then we'll repeat that process for 2, 3, and 4. So there's pin 2. Now this is a basic full step control. There are different things you can do to get like half steps and different sets of increments through these stepper motors. And there's also different modes you can use for more torque or more speed and different things like that, where you have multiple coils active at the same time. I know. But this one will work good just for the our basic input. All right, so let's plug this in and upload it and see if it'll work. Still uploading. We're still compiling, rather. And we should be able to see the little LEDs on here turn on as we go through each of the steps. Now you may or may not be able to see that, but that motor is turning every step there. And because it's going so slow, it's a little hard to see. So let's speed it up so we can see it a little bit better. So you can see that. Now, because we have a lot of other things going on inside this code, it's actually pausing for a little bit longer period of time every fourth step, right? Um, and so let's modify this so we actually get to go a little bit faster. Well, let's do it. Let's do it faster again, and then we'll speed up. So I'm gonna go through here, and I'm actually going to get rid of these other delays, so that way we can speed this up a little bit. So I have this 100 millisecond delay. Let's just do this. And there is a maximum speed I can do this. If I try and go too fast, it won't work. But this is probably still plenty slow. So now I can't actually see the individual steps very well because it's flashing so quickly. We get a nice smooth motion. All right, so that's fun with kind of playing with this and seeing how it works, but let's actually choose something a little bit more practical. So let's unplug this guy. And say I just want to remove a certain number of steps, right? And I'm not trying to see how this works, but I just want it to go a certain distance, right? Whenever I do something, say when I press the button, right? Um, we can actually set that up and we can make this a little bit more convenient for us. So what I'm going to do here is let's actually take out some of the code here and replace it with for loops. And for loops are a good way of automating things that need to be done many, many times, or at least a set number of times. And so what I'm going to do here is I'm going to, instead of saying this is pin mode for all of these, I'm just going to specify the range that I want to do. So I'm going to say for integer I equal to 10. And we're going to say we're saying while I is less than 14. That's the end condition. I'm going to increment it up I plus plus. So in the for loop here, I'm specifying basically the integer I'm going to be incrementing inside the loop, the end condition, and then the increment condition. In this case, it's going up by 1. And again, I really suggest you guys use the reference library here. You can search for 4. Oh, this is not the reference. Let's go to help reference. And there should be a logic section in here. I probably passed it. Here we go, I did pass it. So you can see here's the same structure. For the integer, in this case, I have I'm starting at 10 in this case. It's saying, making sure it's at least this value. They're using semicolons, I use a comma instead. So use semicolons to go between those. And that's all of my pins, right? So what I'm going to do is I'm going to say pin mode of I, because that's the number of pins, as output. And then since I'm doing the same thing for both of those, I can also say digital write I low. And for that to work, I need to put this in curly brackets. So let's curly bracket, close curly bracket. And now that does in 4 lines of code, if you count the curly bracket, what took 8 lines of code. Now here I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, right? I have to keep track of the count, basically what number I'm on, as well as what position I want to move to. So I'm going to make a new integer. I'm not using any of these pins anymore, so I'm actually going to take them out. If I wanted to, I could say start pin or something like that, but I'm just going to take them out. I'm going to say the integer, I'm just going to call it coil, because I feel like I used count already. I did already use count. So we're going to start on coil 1, and we want to go through 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4 if we're going one direction, and 4, 3, 2, 1, 4, 3, 2, 1, 4, 3, 2, 1 if we're trying to go the opposite direction. Right, so in this case, I'm going to set coil 1 to 1. Now here, I'm going to go through each of these, and I'm going to set each one high and low based off of how many times I want to turn. So in this case, I'm going to replace this whole thing with a loop that only has basically the same one in it. So here, I'm going to say for integer. Again, in this case, I'm not going to use 110. I'm just going to do a certain number of values. So I'm going to start at 1. And I'm going to go, let's say, 100 turns. Let's just start at 0 and we'll go 100 turns. Right, so this is actually going to go from 0 to 99, which is the same as 100. And again, we don't need to use this I inside this loop. I'm going to actually use my count. So here, I'm using my coil. Right, so I'm setting the current coil, which is 1. And then I'm going to increment coil by 1. So I'm going to say coil plus plus. And we're going to say if coil greater than 4, because again 4 is as big as it can get, we're going to set it back to 1. So if we think about how this logic is going to work, right, we have coil starts off as 1. So I'm going to start off, I'm going to go through this 100 times. So coil is 1, high low, coil goes up to 2, high low, coil goes up to 3, high low, coil goes up to 4, high low, coil goes up to 5. Now this is true. Resets the coil to 1 and then repeats the process. So this should turn the motor 100 times with that same delay timing there. So let's try uploading this guy. So we'll plug it in. Let's move this down so you guys can see it. And then we will hit run. So it's actually still running the code from last time, so it's still just going. I don't have these pin 4s, so I forgot to erase that. Let's erase that. So it looks like this is not running through currently. I don't see it setting the output. Oh, I know why. We're using the wrong value here. So my coil is, I'm doing a pin 1, 2, 3, 4. Really I want my coil to start at 10 and then go through 13. So I'll say if coil is greater than 14, we'll set it back to 10. Let's try that. Again, in this case, the coil is my pin, and I didn't create a mapping between the pin number and the input number. There we go. Then move 100 positions. You don't really see the stop very well in that, so let's modify this a little bit. We'll put up delay of that, so we can make sure that we actually are moving 100 steps and then stopping, and we can actually see the stop. So there's 100 steps. Right. So now we can actually take this one step further. We can add this our sensors to that. We'll make one more video where we actually use our sensors to control the different things we have on here. And then that'll be it for this module.